Greetings and welcome to the series of lectures on rational expressions and rational functions. 5.3, Addition and Subtraction of Rational Expressions. When adding and subtracting rational expressions, we're going to follow the same process as regular fractions. So we have two types. One is they have the same denominator, and the second type is they don't. Okay, they have different denominators. Let's see an example where it has the same denominators. If so, like 4/9 plus 2/9, they have the same denominator. Therefore, I can write it as 4 plus 2 all over 9. 4 plus 2 is 6. 6/9 can be reduced to 2/3. Okay, so let's try a radical expression. We'll try x over x squared minus 1 plus 1 over x squared minus 1. They share the same denominator, so I'm going to rewrite it as x plus 1 all over x squared minus 1. Because x plus 1 is as simplified as I can get the numerator. I can't combine like terms, that's what I mean by simplified. I can't add any like terms here, but I can see if the fraction can be reduced. So I'm going to factor the denominator here. X plus 1, x minus 1. X plus 1 is still on the top. I can reduce. They both share an x plus 1 in common. Therefore, my final is 1 over x minus 1. All right, let's try another one, this time subtraction. So 2x, since they have the same denominator, 2x minus 5 all over x minus 2, minus x minus 3 over x minus 2. I'm going to go ahead and rewrite it under the same fraction. Be very careful. It's subtraction of the whole entire numerator all over x minus 2. Distribute the negative. 2x minus 5 minus x plus 3 all over x minus 2. Add like terms. 2x minus x is x. X minus 5 but plus 3 is x minus 2 all over x minus 2. Well, I can reduce this. X minus 2 and x minus 2 can be reduced. X minus 2 goes into x minus 2 once. X minus 2 goes into x minus 2 once. That's 1 over 1. Reduces down to 1. So addition and subtraction with different denominators, we find the least common denominator. Now, a least common denominator for a set of denominators is the smallest expression that is divisible by each of the denominators. Let's try a regular fraction. So if I have 13 over 14 plus 7 over 30, I need to find the LCD of 14 and 30. So I look at its primes, right? I look at its factors. 14 is 2 times 7. 30 is 2 times 3 times 5. They each have the 2. So I do need the 2. And then I need everything that they don't have in common. So the LCD is going to be 2 times 3 times 5 times 7, in other words, 210. Now that I know the LCD, I'm going to rewrite the fractions using the LCD as the denominator. So 3/14. 14 times 15 will give me the 210. What I do to the denominator, I must do to the numerator. 30, to get to 210, I have to multiply it by 7. So what I do to the denominator, I have to do to the numerator, 7 times 7. Giving me 3 times 5 is 45 over 210. 7 times 7 is 49 over 210. Now I can do my addition. They have the same denominator. 45 plus 49 all over 210 will be 94 over 210. But because they're both even numbers, I do know a 2 lives in there. So I can reduce by 2, leaving me 47 over 105. right, so let's try a little bit more complex problem. -2 all over x squared minus 2x minus 3 plus 3 all over x squared minus 9. Now they don't have the same denominator, so I need to figure out what the LCD is. So I'm going to factor both of the denominators. X squared minus 2x minus 3 will factor into, let's check it out, x and x, negative meaning there's one negative and one positive. 3 times 1 will get me 3. 3 minus 1 will get me the 2, and I know the negative is on the 3. Okay, that is factored. X squared minus 9 will factor into x minus 3, x plus 3. Therefore, the LCD will be everything they have in common. So they have the x plus 3 in common, or x minus 3 in common. But then I need everything that they don't have in common as well. X plus 1 and the x plus 3. Okay, now that I know the LCD, I'm going to rewrite each of the fractions with the LCD in the denominator. So let me first write it with its factors, as its denominator is written as factors, and 3 all over x minus 3, x plus 3. Okay, there's a plus symbol in there, addition symbol. All right, the first term has x minus 3 and x plus 1, but it's missing the x plus 3. So I need to multiply both the denominator by x plus 3 and the numerator by x plus 3. For the second term, it has the x minus 3 and it has the x plus 3, but it's missing the x plus 1. So I'm going to multiply both the numerator and the denominator with x plus 1. Okay. -2 times x plus 3 all over x plus 3, x minus 3, x plus 1, plus 3 times x plus 1 all over. I'm just going to reorder it to make sure that it's in the same order as the other one. X plus 3, x minus 3, x plus 1. Now that they have the same denominator, I'm just going to add now that they have the same denominator, I'm going to add the numerators together. Right? Putting out of room here. Okay, so let me transfer it over to a new page really quickly. -2 x plus 3 plus 3 x plus 1 all over x plus 3, x minus 3, x plus 1. Okay. Go ahead and move that up some. Okay. I'm going to leave the denominator alone from now on. I'm going to go ahead and leave it into its factors, but I can simplify the numerator a little bit. I'm going to do the distribution of the -2 as well as the 3. -2 times x is -2x. -2 times 3 is -6. Plus 3 times x is 3x. 3 times 1 is 3. All over x plus 3, x minus 3, x plus 1. Add like terms for the numerator. -2x but plus 3x is x. -6 plus 3 is -3. plus 3, x minus 3, x plus 1. Reduce. If possible, reduce. X minus 3 goes in once, x minus 3 goes in once. Therefore, my final answer is 1 over x plus 3, x plus 1. That's it. I'm not even going to multiply it out. I can leave it as the factors. Okay, so let's do the same thing here. I have different denominators, so I need to find the LCD of each denominator. To save paper, I'm just going to try and work in a small space here. I'm going to factor the first denominator, 2x plus 5, and x plus 5x minus 5. Therefore, they share the x plus 5 in common, but they also need this 2, and they need this x minus 5. So the LCD is 2 times x plus 5, x minus 5. Right. Look at the first term and see what it's missing. It has the 2, it has the x plus 5, but it's missing the x minus 5. There we go. So I'm going to multiply x minus 5, x minus 5, 2, x plus 4, 2 times x plus 5, minus, well, let's look at the second term. It has the x plus 5, it has the x minus 5, but it does not have the 2. So I'm going to multiply both top and bottom by 2. X plus 5, x minus 5. Okay. That leaves x minus 5, x plus 4, minus, well, 2 times 5 is 10, all over the LCD of 2 times 5, x plus 5, x minus 5. I am going to simplify the numerator. So I am going to have to FOIL the first term. X times x is x squared. X times 4 is 4x. Negative 5 times x is negative 5x. And negative 5 times 4 is negative 20. And then don't forget that I have this minus 10 hanging out here. All over 2, x plus 5, x minus 5. Okay. Let's simplify the numerator. Add like terms, in other words. X squared. 4x but minus 5x is a negative x. Negative 20 minus 10 is a negative 30. All over 2, x plus 5, x minus 5. Okay. Then I look to see, can I factor the numerator? And I can. The numerator is going to factor into x minus 6, x plus 5, all over 2, x plus 5, x minus 5. Now that everything's factored, I can reduce. X plus 5 goes into x plus 5 once, x plus 5 goes into x 5 once. My final is x minus 6 all over 2 times x minus 5. Now the only thing that I do want to say is be very careful when you're inputting any of these answers into the system that we use for homework. Use the option button. When you have a complex fraction like this, or a fraction which has multiple terms, I find it easier if you use that little option button. So click in your answer box, and then there's a little arrow that pops up at the very far right of your answer box. Click that and you'll see a fraction. Use that fraction to input your answers, and I don't think you'll go wrong. All right, first things first with new problem, 2x minus 2 all over x squared plus 4x plus 3 minus x minus 1 all over x squared plus 5x plus 6. First thing we want to do is factor anything and everything we can. So the numerator I can factor as 2x minus 1. The denominator I can factor as x plus 3x plus 1. The numerator here is just an x minus 1. The denominator is x plus 3x plus 2. Okay, now that I have everything factored, I do need to find LCD. They both have the x plus 3, so I need it, but then the first term has an x plus 1, and the second term has an x plus 2. Okay, so my LCD is going to be x plus 3, x plus 1, x plus 2. Okay. Now I just need to see which fraction needs what before I start combining everything. All right, let's change colors here. The first term has the x plus 3 and the x plus 1, but it doesn't have the x plus 2. So x plus 2, I'm going to multiply both the denominator and the numerator with x plus 2, giving me 2x minus 1 all over x plus 3x minus 1 minus, okay, second term has the x plus 3, has the x plus 2, but does not have the x plus 1. Multiply both the denominator and the numerator with x plus 1. X minus 1 all over x plus 3x plus 2. Okay, so far so good. Okay. That leaves us 2 times x minus 1 times x plus 2 minus x plus 1 x minus 1 all over x, I don't know, I'll just do them in order numerically. Minus 1, x plus 2, x plus 3. It really doesn't matter which order you put it in because it's all multiplication. Now here's what I could do. I could FOIL all of this and then add like terms and then see if it's factorable and then reduce. But if I'm clever, both terms in the top have an x plus 1, so why don't I factor that out? It's a common term. Okay, so if I factor it out, that's x minus 1, leaving behind 2 times x plus 2, x plus 2, minus x plus 1. That's a big parenthesis around there. All over x minus 1, x plus 2, x plus 3. Well, that simplifies things a little bit because look, the numerator has an x minus 1 and the denominator has an x minus 1. Okay. Now I'm down to 2x, 2 times x plus 2 minus x minus plus 1, sorry about that, all over x plus 2 times x plus 3. Again, here's one of these situations where you want to sit back and think. You cannot eliminate the x plus 2 yet because you have this subtraction in the numerator. So I do need to distribute the 2 and then add like terms. Distribute the negative as well. This gives me 2x plus 4 minus x minus 1 all over x plus 2, x plus 3. Going to add like terms in the numerator. 2x minus x is x. Plus 4 minus 1 is plus 3. Interesting. X plus 2 all over x plus 3. Well, look at that. We can reduce again. X plus 3 goes into x plus 3 once. X plus 3 goes into x plus 3 once. All of that is left to x plus 2. Right? Parentheses just for emphasis there. Right, sometimes it's a little bit complicated or a little bit confusing as to what we can factor. Anytime that you kind of see a leading number with a variable, generally that's when you want to factor out a negative 1. All right? So, if my first term is completely factored as x squared over x minus 7 plus, my top term is also factored all over negative 1 times x minus 7. Okay? They are not the same denominator. The second term has a negative 1 in it. So to be able to have the same denominator, there's one of two things I can do. One is I can multiply the first term, both the denominator and the numerator, by negative 1. Or I can multiply the second term by negative 1, because negative 1 times negative 1 is 1. That would leave me x minus 7 and x minus 7. I'm going to go ahead and do that. Negative 1, negative 1. Okay. If I multiply both numerator and denominator by negative 1, that leaves x squared all over x minus 7 plus negative 1 times 6x is negative 6x. Negative 1 times positive 7 is negative 7 all over. Negative 1 times negative 1 is 1, so that's x minus 7. Now that they have the same denominator, I'm going to combine them. X squared minus 6x minus 7 all over x minus 7. Can I factor the numerator? See, 7 times 1 is 7. Yep. X minus 7, x plus 1, all over x minus 7. Okay. The x minus 7s will reduce, leaving x plus 1. No parentheses needed. Okay, just a couple more examples, and then I'll let you go on your merry way. All right, 2 minus 9 over 3x plus 1. You do need to remember that there is a denominator with the 2. So the LCD is going to be 1 times 3x plus 1. Well, 1 times 3x plus 1 is just 3x plus 1. So I need to multiply both the top and the bottom of the 2, the numerator and the denominator, 3x plus 1 over 3x plus 1 times 2 over 1 minus, and since the 9 already has the 3x plus 1, we can leave that alone. That's going to give me 3x times 2 is 6x. Don't know why I changed colors. 6x. 1 times 2 is 2 all over 3x plus 1 minus 9 over 3x plus 1. Now that they have the same denominator, we can combine them into one fraction. 6x plus 2 minus 9 all over 3x plus 1. Add like terms. 6x, 2 minus 9 is minus 7 all over 3x plus 1. The numerator I can't factor. The denominator I can't factor. There's nothing alike in either one, or I should say it's not alike. Therefore, that is my end result. All right, last example. Let's write an expression for the sum of a number and twice its reciprocal. Well, a number, I'm just going to call a number. I'll call it x. Its reciprocal would be 1 over x. Twice its reciprocal is 1 over x times 2. And the sum of a number and twice its reciprocal is adding. So here is my expression. X plus 2 times 1 over x. Right? So I'm going to simplify this as much as I can. X plus 2 over x. What's the common denominator? Well, LCD is going to be x. So I need to multiply the first term by x over x. That will give me x squared over x plus 2 over x. Last step, let's combine fractions. X squared plus 2 all over x. That is my final because x squared plus 2, I cannot factor it. So, all right, that is it for this lecture. Until next time, be seeing you.